All right, welcome to week 17 of IS50B. And so some of you were looking at modding Skyrim. I haven't really touched it, but this page here will probably walk you through the process of getting the creation kit installed and going on it. Like I said, you don't need to really kill yourself on this mod. Just do something. Just do something. You know, earn your points. So modding Skyrim, modding Minecraft, just do something cool. It doesn't have to be gigantic. Okay, so you guys are going through the Laylee tutorial on behavior trees. Yeah, cool. All right, so what I would like to talk about today. First of all, last time we talked about physics a little bit, right? Then physics, fall, snowflake. Yeah. So last time we did a little physics engine, and we can modify this to do water if we wanted, by simply allowing things to move horizontally. If there's an opening, then that would simulate water. If the current spot is sand, if the place below it is open, then it moves down. And then it's checking here to see if the left is open and the right is open, and then it checks those two. And so all we would have to do is add two more checks, one for horizontally and one for horizontally the other way. And then if the two down below are taken, then it would try sliding sideways if it could. And by doing that, it would actually implement water. And so a drop of water would hit and it would roll until it fall down. So what I'd like to do today is maybe do Doom. Let's see if we can get that done in an hour and a half.
Doom? Oh yeah.
Something like that. Let's give it a shot. All right, so then Doom CC. Thing just always like flips out. Like, just let me type, dude. Just let me type. All right, so let's start off with like a mapu. Let's do a vector of chars named map, which is equal to x p 4, 5, 6, 7, 8, 9, 10. YYAP. It's 9. Okay. Okay. So that makes a two-dimensional vector, maybe. Let's see if that works. Doom.cc. So we got a map, and so we can edit this map, you know, to put in quarters or monsters or whatever. This is a pretty good starting place, I think. And I guess we can call this print map if we want. This 1, 2, 3, 4, 5 lines of code. Whatever. Let's comment this out. We're not really going to be printing the map. We're going to be drawing to the screen. Okay, so let's see. We'll start off by calling clear screen. We'll wipe the screen, and then let's see, where should the player start? So let me make a player class, struct player. This player will have an X and Y location, let's say. Double X equals 0, Y equals 0. So how do we want to have the world work? Do you want the center of the world to be 0, 0? That might be kind of an easy way of doing it, I guess, maybe. Or we can have like the top left be 0, 0. And the bottom right be 10, 10 or 9, 9, rather.
Top left would be easier, I think.
Okay. Then we will start the player at, let's say 5, 5. We'll just make a note to that. Top left corner is 0, 0. Bottom right is 9, 9. Okay. It's always important to note your coordinate systems. So otherwise people, like, maybe it could run from -1 to +1, right? And just everything is a float in between the two, you know? So there's a lot of different ways you can do coordinate systems, and for some reason people always assume that people just use the same coordinate systems as you, and okay. So, do we want to double? Or we just move 1 square at a time? Yeah, let's just do double. Let's see if we can make that work. And then what else describes a person in a video game? This is going to be a first-person shooter. So what else do we need? Collins, Rosenberg, you've played first-person shooters before, right? Hit points. Int, double, int. Wait a sec. Start off at 100 health or something. Keep it simple, stupid. Hey. Or are you talking about the rock group? I was offended when my 3rd grade teacher told me to keep it simple, stupid. You said what to me? What? What's that, mate? What's that? Heretical. Uh-huh. We're not on the rendering part yet. What else though should go into describing a player in a first-person shooter? Like, we got a Doom guy. Like, you guys all know Doom, right? Like, we're doing Wolfenstein raycasting. Yeah. Told you we're gonna get to it this semester. If it works. Literally, I don't think I've ever actually coded this before myself. So we'll find out. We're doing it live. Like, yeah, let's look at Wolfenstein. No, not that one. This one. Okay. So, are you guys familiar with these kind of old school first-person shooters? Speed, arms, like weapons. Weapons? Okay. Alright, yeah, sure. So we can have a bit field or something, and weapons, shotgun. All right, so we got Prado and we got Harlan here. So we're gonna try and make like Wolfenstein using PuTTY. Okay. So what else describes a dude, a Doom guy? What else? Yeah, Wolfenstein maps are literally like this. It's just a 2D. It's just a 2D array. So, what else? Go on. You guys are game designers. We're designing a game together here. We got 2 hours before the data science lecture. Let's come up with some ideas. Come on. And try and code them live. Movement speed. Yeah, that's right. Somebody mentioned that. Double movement speed, and let's say you can move 1 unit per second. Let's say. So the world is 10 by 10. That seems like a reasonable enough thing. So imagine we're looking down at the world from above. The player is starting off here. What do we need to know about the player? Come on. If we're gonna render a frame, if we're gonna render the walls and things like that, what do we need to know about the player? Direction. Yes, very good. So double angle. So we'll start off looking north. 0 is north, 90 is east, 180 is south, 270 is west. What are radians? I don't know. Okay. I mean, Unreal Engine uses degrees, so yeah. Yeah. And so this is a 2D game that is going to look 3D. So we actually don't need to have a angle vector for yaw, pitch, and roll. All we need is yaw. Yaw is this. Okay. Pitch is this. We don't have that in a 2D game. And roll is this. We also don't need that. It would probably make people sick if we did. Okay. Armor, maybe? I don't know. Did Wolfenstein have armor? Had ammo? It should probably have an ammo count or something like that. Lives. I don't know. Let me worry about that later. Ammo, we'll just start off like 100 ammo or something. We'll worry about that later. Okay. Jump height. What? Jumping? It's a 2D game, Prado, that we're just going to pretend to be 3D. Okay. So, yeah, we're starting, basic. All right. So, field of view also would be a big thing here. So, field of view will just default to 90 just to make math easy. And maybe we don't even bother with it for now. We'll just default to 90. All right. So, let's start off by getting just a input loop in. So we're gonna build a whole game from scratch, and again we're doing this live, so who knows how far we'll actually get, but let's give it a shot. So first thing we should do is have some sort of like input loop, right? So the WASD and arrow keys or mouse, arrow keys. Yeah. I don't think Wolfenstein necessarily had mouse input. Maybe it did, but those early games you could play just on the keyboard, right? So we need to do what? So moving. What do we do to while true? It's going to be our main loop. Okay? So in a main loop, you do the following things. Input from the user. You do network communications, which we're not going to do here. We do AI for monsters, which we might get to later. Then physics engine. If you shoot a projectile, you have to make it move every turn, and then you have to pull up the start menu, apparently. Thank you. And then you have to render a frame, and then we will sleep to cap the frame rate. So we will start off by just doing uSleep 1 second divided by max frames per second. So max frames per second, let's make that a const, int max FPS equals 30. So we'll just cap the frame rate at 30 for now, otherwise it'll probably fly out of control. And usleep is in the Unix standard library. If you're going to port this to Windows, to modify it. Unistandard.h. There are functions in the C++ standard library like sleep4 and things like that you can use. Okay. So before we do anything else, let's just start off by doing like frame equals 0. Scout. Move cursor. So move the cursor to the top left corner of the screen and see out frame. Not updating because there we go. So we got a frame counter running. Cool. We can have that running just in the top left corner if we want. All right. Paint controls, left, right arrow keys to turn. Can't strafe. We could add strafing. I don't see why not. Okay, so we've got a player. We need to make a player. We got a player class. We haven't actually made a variable of that type yet. So
if you're gonna do strafing, you're gonna have to like bind it to a different button or something. Otherwise, you're gonna have to actually add mouse support, which might be a little more than we want to do, at least right now.
We could do like WASD and then arrow keys.
I guess, yeah.
So we need to make a player. So we'll just do player. What's a good name for a player? Doom guy?
Of course.
Right. Player Doom guy.
Or BJ Blazkowicz, either one.
Doomer guy. Boomer. There you go. Duke Nukem. Doom guy. That'll work. Okay, so every frame we do, we're gonna move the cursor up there. Just displaying frame counter right now. We're capping the frame rate. That's all working. Okay, but do you guys understand these are the phases that you kind of go through when you make a game? And we're talking about like this whole semester we've moved from the Unreal Engine doing everything for you to like sort of dropping down a level and seeing how does rasterization work? How does the culling thing work? How do you do BSPs and things like that to, discard large chunks of geometry and stuff like that. So here we're gonna write a game engine kind of from scratch. So input from the user, Muya, how do we do that?
I don't know, using your quick read library.
Yeah, I have to look it up too.
quick_read into a char.
Yeah, we have to like turn on non-blocking IO first.
Oh, set raw mode, true.
Colors. Is it? No.
I think it's in colors.
Is it in colors?
You go to colors, and there's quick read dot.
Yeah. So I could just copy all of this, and I guess. I know you want me to make that automatic.
Yeah. It's set raw mode, I think.
So cursor mode off, mouse mode on. I don't know.
Yeah, set raw mode true. That involves the quick read.
There. And I'll need this at a certain point too. Yeah, I guess I'll just do this. Okay. Cat, Doom, and quick read together, and we will write this into a file called A. And so I just concatenated those two files together. That's why it's called cat, by the way. It's used to concatenate two files. And I already got that one. All right, cool. And so I can just come down here and comment all of you out. Move A to doom.cc, then doom.cc, and now I've got all of the code down there just for me to steal from. So I'm just going to start off by turning set raw mode true on. You've never seen that before? You've never seen cat before?
Never seen it be used to concatenate.
It's not actually used as a file viewer. I mean,
yeah, that's a good point. I never thought of that. That's really cool.
okay, so raw mode will turn on, and then what else do we need to steal here? Mouse mode, cursor mode, getting the terminal size, bailout. And should probably do that, huh? Okay. Mark X. Y single quote X. Jump up to the top of the file. And just do that there. Let's not do mice. It's too much work for now. We can add it in later if we want. All right, so what we're going to do is just add in this kind of boilerplate here. And so what this will do is it'll allow non-blocking I/O to exist. This one says when the program exits, call this function bailout. So this is a callback. And so this is part of the standard library, by the way. A lot of people don't know about it, but you can set up a function to run when your program quits by any means. It's actually hooked into the exit system call, kind of. Yeah. The exit standard library call, which calls the exit system call, but it calls everything that you've registered with exit before it calls the exit system call. So yeah, so the upshot is when our program dies, it will call bailout. Bailout will turn raw mode off, which will leave our terminal in a decent enough state. And we say that when they hit Control C, rather than Control C killing our program, we want it to call std exit instead, which will call this function. And so this will keep everything nice and tidy. All right. And then delete this stuff here. I've already brought it up. I'm not going to worry about mice. Got you, got you, got you, got you. Yeah, I guess we get the terminal size. Y to Y. So we'll get how big the terminal is as well. Might as well. And then we can just call quick read. We don't need any of the rest of this for now. Okay. And it returns error if nothing is read. Okay, so we're going to get input from the user. So we're going to just say, what does it return, an int or something like that?
Yeah, it returns an int.
Returns an int, yeah, okay. Int char, don't call it char. Equals quick read.
I love int ch.
Equals nothing happened. Congratulations. Which is what's going to happen most of the time. Then we will, yeah, do absolutely nothing. Else, if, I mean, I guess we don't need to handle that. Okay, so if ch equals w.
Yeah, I never understood why we always had if statements for like I always would just use that when I'm waiting for input or something.
Mm-hmm. Yeah, it just it's I like being explicit about it because like people are like, well, what happens if nothing's read? And so I put it in there so that people can see what gets returned if nothing is read. You know.
Ooh, also JT's testing out the stage channel right now, which is pretty cool.
The what channel?
The stage channels. They just finally officially added them today.
Michael Juarez is listening in. Nice. Okay, so if we read a W, then I guess we can just do this. See out the frame. We can see out the Doom guy's X and Y position. Doom guy dot X. Doom guy dot Y. Right. And so basically, as we do WASD, then we will. Let's start off with just orthogonal, so W moves north, and right? You guys with me on this?
Yeah, that makes sense.
And we'll just do So what are we doing for x? Horizontal. Okay. So if we hit W, then y is going to decrease by 1, right? Doom guy dot y minus equals. Do we decrease it by 1? We can start off with 1 and then make it better later.
Decrease it by movement speed, I guess.
We should, but let's just start off doom guy dot y. Jeez, what's going on here? Okay. Let's just start off with that, and then we'll build in, because we have to account for frames per second, right? And we have to account for the movement speed of the player, which is movement speed. Yeah, okay. Fine, we'll just do it all at once. Movement speed times 1 over max FPS, and that's assuming we're getting max FPS. In reality, we should.
You would have an actual current FPS variable or something.
That's correct. Yeah, you would at the start of the loop, you would take the current time, minus it from the last time, and then then you divide by 1 over that, and that gives you the frames per second that you have. Or if you don't 1 over it, it gives you the delta time. So that would.
But we're probably always going to be hitting max FPS.
We're going to be hitting max FPS. I'm just not going to worry about it right now. Unless something goes horribly awry, we should be able to run this at 30 frames a second. Okay. So doom guy minus 1. This is going to be doom guy dot movement speed. So that should be good. So then we'll just do this for WASD, and then we'll. What we need to do is do the angle, right? And so you move in the direction of the angle. We're going to start off with just an orthogonal top-down, like what Harlan and Walker are doing with their top-down stick shooter. Right? And so A would be X decreasing, and then S would be Y increasing, and D would be X increasing, and then we need to we need to add collision detection next. But let's just see if this works, because we.
You left it has left as minus equals for D.
Thank you. Yes, and we need to add collision and things like that, but we've put a lot of stuff in. We added in non-blocking IO, and we haven't even tested it yet. Structured binding declaration set but not used. Yeah, that's fine. All right, so if I hold it down, you can see I'm holding down D right now, by the way. So you see he's sliding to the right. I hold down A. He slides to the left. I hold down W. Y is decreasing. Hold down S. Y is increasing. If I hold down both, looks like only one of the keys gets read. And I can run right out of the world, right? Because there's no...
Oh yeah, I always wondered, how can you do multiple key press? Would you have to do like threads for that?
The game is turning out to have so many stupid little quirks in it. Yeah. Threads. No, I think it's just a limitation on the console, honestly, because there's nothing. I'm like the quick read will handle having W and D both held down. I think it's just your keyboard is just repeating one of the keys and not both of them. That's my guess. Yeah. It's kind of a limitation in this whole PuTTY system, because you don't get notified when a key is pressed and released, only when it's pressed. And there's a key repeat setting that if it's held down, it'll send a repeat on it, but it doesn't actually tell you when the thing's released. So, yeah, that might be a limitation here. Anyhow, so okay, we've got WASD working. We now need to do it with the angle, right? So if they're right now, angle is 0. We need to add some trig to this, right? First of all, let's do the angle, right? So let's see what the angle of the user is. Angle doom guy dot angle. All right. And so if the character they enter is left arrow, then we will rotate them left. And so we do that.
How much?
How much? That's a good question. And the rest of you guys can chip in too. Are you all muted? Here, I'm going to unmute all of you guys. I want this to be a cooperative endeavor. I don't want you guys just staring at you. There you go. What's going on, Prado?
Me here.
Good. Harlan is muted himself. That's fine. So, how fast do you guys think that the Doom guy should be able to rotate? Like, how many? This is like you can move like 1 meter per second. That's our units here. No, I'm suffering from the second vaccine shot. Congratulations. I'm glad you got your second shot. Maybe we could hang out again. That'd be cool. All right.
We could have a turn speed.
I feel like
that's just like a scalar.
Yeah, but like how fast? How many degrees per second? 5 degrees per second?
Okay, whatever. 20 degrees per second. I don't know. We'll experiment with it. We'll get there.
45 maybe?
45 feels a bit quick, doesn't it?
I don't know. Let's find out. So double angular velocity, something like that. Angular speed.
Yeah.
Speed, velocity.
Yeah, just velocity as direction.
I commit crime with both velocity and direction. So 45 degrees per second of rotation. Angular speed, rotation speed. It's called rotation speed. Okay. So if they hold down left arrow, we want the Doom guy dot angle, right? So they're going to rotate to the left, so the angle will decrease. So minus equals.
That'd be if you're turning left, then you're going in positive. Positive.
That was not bad.
Counterclockwise, right? Counterclockwise.
Yeah, counterclockwise is positive.
So we have 0 being north, 90 being east. So left arrow would be...
Wait. Oh, okay. Never mind. I was building it off of like the math coordinate system.
Yeah.
Where 0 is east and 90 is north.
Right. Too late. Okay.
Yeah, whatever. We'll follow that.
I apologize for the jam, by the way.
That was an amazing jam.
Rotation speed. And we are going to multiply this by our frame rate. Which I guess we can compute.
We could probably calculate it.
We should probably get around to that, huh? Okay.
Let's just do the right arrow. We'll get to that a little later.
Double delta t. We'll start off at 1 over 30, and then auto. Oh Lord, what is it? Can you get the time to get the current time?
You want chrono?
Yeah, the chrono. I don't want to Google it right now. Yeah, just get now, right? And then down here we'll.
So you have to. Oh, this is right.
Use a steady clock : colon.
Yeah.
Colon. Okay, so then this will all become. Right.
Okay, I have it ready whenever.
Yeah, just paste it into M.
Oh, okay. Type it.
9x 9s delta t. And so auto last time is equal to chrono.
You're doing a better job than I am.
Steady clock. Sorry, taking too long.
Yeah. Okay, I literally just found it.
Duration, no. There you go. Time point. There you go. It's in chrono. So we get the current time, and then this would be stood : chrono : steady clock. Okay. So that will be the last time, and then we'll get the current time. And if we were smart, we would sleep based on the difference. But whatever, we're not smart. Okay, so current time is equal to now, and so...
Shouldn't that be outside the loop? Or at least shouldn't current time exist one scope backwards?
Yeah, and so delta t is going to be equal to
never mind, sorry.
current time minus last time. We need to duration cast this probably. Duration cast to a double. Current time minus last time. We're good? We're good? We're not good? Was this chrono? Something? Chrono? Colon. Not good. We don't like it. No matching call.
I think, don't you just do count? Like, time, last time, or count?
Duration. Doubles. The whole thing is so stupidly designed. Okay. Duration. Chrono. Duration. Oh my gosh. Oh, that's returning a double. So we have to take this whole thing here and call count on it, and then it works.
Yeah.
Yeah, this is the issue I have with the new standard library stuff. Like, somebody thought this is, you know, an adequate replacement for clock, right? Because clock just returns an int. Int time equals clock, right? And it just gives you an int, and you can like subtract it, right? Somehow somebody thinks this is a more readable system, right? So that should work.
Gotta add right arrow as well.
What's up?
Right arrow.
Where?
Returning right.
Yeah, but we need to output the delta t too. Delta t is delta t. Just make sure we're computing that correctly. This is something you have to do in every game, you guys. You have to figure out how long it's been since the last frame. And then we'll 4s write this, and so delta t is increasing in time. Oh, that's because I did not do the thing that I was going to do, which is to say last time is equal to current.
What?
It's funny. Oh my gosh. G++ it's funny. It's what happens when you just start randomly hitting the keyboard. Alright, there we go. So delta t is about a third of 0.03 seconds. Okay, so you guys see that? So sometimes it takes a little longer, sometimes it takes a little less. And then if we wanted to be, if we worried about, because we're sleeping for just like a 30th of a second, right? And so if we wanted to be more precise, we can compute how long it's been since the last frame and not sleep for as long, right? So we don't, so our max frame rate doesn't impact our frame rate negatively. But this is fine. Like I said, we're not too worried about that. Okay, so we're gonna run this, and I hold down right arrow, and you can see that, oh, right arrow is, oh, I copy pasted, that's fine. So we can rotate around, and we should do an angle mod on this, right? Because we can go right past 360. Yeah. Okay. So we need to have, ooh, we need a math library, don't we?
Oh man, if only you had a library that had matrix math inside of it. Wouldn't that be nice?
That'd be nice. Can you put that up in temp for me?
I'd love to.
Okay. And then chmod it so I can view it. Okay, so yeah, we're not going to handle mice today, I think. Oh, that would be really funny. Okay, so we've got this all going. This just needs to be a plus equals, and then we are going to navigate around. Now we need to do collision detection, right? So rather than moving immediately, we need to do what? We need to bounce, right? So if we hit a solid wall, we can't walk through it, right? And so there's a couple different ways we can do that. You do this in a really funny fashion. We just make a new player. Old Doom guy. Equals Doom guy. It's save where he was last frame. And then if we move here and he is now within a wall or something, then we just restore him back the way he was before. It's definitely a better way of doing this, but this is amusing to me, so we'll do that. Okay, so we need to see if the player is now within a wall. So if map dot at row first, okay, doom guy dot y dot at doom guy dot x is equal to wall. Yeah. Just do that. So if we can make the constants later. So if the guy is in a wall, then we just say doom guy is equal to old doom guy, and we should just store the location, but this is actually just really amusing to me. So I'm just going to do that. And then this should do collision detection. Let's try that out. Sorry, www. And we try going in there. Yep. So I can't move up any higher. I can move right. And I try going out of bounds, and nope. So I'm trying to move northeast right now, and it's not letting me move that way. So there we go. Got collision detection.
And the movement would be really easy to scale by angle, right? You just got to do times the sine of the angle for...
Yes.
Well, actually, since we're using a different coordinate system, it might not be sine.
Well, right now we're doing orthogonal, but yeah, let's add in the angle, right? Yeah. So, but yeah, do you guys see this? This is like one line collision detection. Like, I'm not even casting explicitly between double, which that is, and int. I'm just allowing the rounding to do it for me. So that's extra as hell. Okay, so it is in temp mix fantastic library. Okay, so copy temp mix fantastic math. There's a whole thing? Okay. All right. Make a directory for this. Okay, so Nick's made like a vector 3. This is kind of what we were working on this semester earlier too, and he definitely went all out. So we got a rotation, translation, things like that. What I was thinking of would be nice. What is this warning about? Order of operations, braces around scalar initialization. Anyway, so what I was thinking about was just angle mod, and so. This inline void angle mod double. All right, so cap wrap around degrees. So 360 turns into 0, negative 10 turns into 350. You guys understand? So. The doubles we can. while d is less than 0, d plus equals 360. We'll call it a day.
Yeah, I think there are baby geese in the backyard. I think there are
Baby geese in the backyard. Oh, Ada, photos, please.
No, like in the lake backyard.
Yeah, go take a photo.
If only modulus actually worked in C++, then you wouldn't have to do a while loop for that.
Yeah, but these things shouldn't. This is so bad. Good enough for college. Okay, so. Yeah. So yeah. Okay. Yeah. All right. Angle mod. All right, and this is called math.h. Okay. Include math.h. All right, so basically we'll just slap an angle mod in there, and that will keep it within reason. Angle mod doom guy dot angle. Okay. So did you guys understand why I did that? I want the, see when I turn to the left now, rather than going negative, it wraps around to 350, and then if I go up the other way, if I go past 360, just, okay, this guy's turning really slowly.
Yeah, I guess 45 was actually a bit slow.
Okay.
Say 90 is probably, or maybe even 120 or something.
Q, just break out of this. Okay. Quit. Yeah, twice as fast, sure. Yeah. It's a little slow, but okay, whatever. Good enough.
Sorry, they're very far away. So.
Aw, baby geese. Aw.
Sorry, that's a bad
Nah,
photo.
those are good photos, girl. Thank you.
They're horrible.
Okay, so now the time has come to do trig, and so we need to move the person not north if they hit W, but forward. So how do we get the forward vector out of an angle? So if the angle is 0, we want it to be north, and if the angle is 90, we want it to be a vector pointing east.
So cosine for y and sine for x is basically backwards.
Okay, so we want, yeah, because our coordinate system's weird.
Yeah.
All right, so we want to have a double vector forward.
Do we need a forward vector? You can
No.
technically do all the math right on the
We
line.
could do it directly. Do we want a forward vector?
I like the idea of just having the angle relative to the coordinate plane. I like that a lot more than having an actual vector. It's a lot simpler.
Yeah, but we're going to be doing scanline ray tracing.
Oh, right. That's a good point.
So the...
Oh, you can use my vector. I have a vector in the math library. And it uses floats. Or doubles. Can't remember.
Yeah, let's just start off with just doing it with the trig way. So, cosine for y and sine for x.
Yeah, it'd be backwards because 0 degrees is normally on the x, but now it's on the y. I think they use radians. So.
Oh, yeah, we have to convert. We have to convert to radians.
And I have CMath included through math.h, so you can use m_pi for pi.
Maybe we should do radians.
I like degrees though.
I know, it's easier to think in. I'll just...
Just add a multiplication there, it's not a big deal.
No, I'm going to do it properly. Alright, angle mod, and then we will do degrees to radians, double D to R. So if we take in degrees, then we will D divided by equals 360. D times equals 2 times m pi. Right.
It's just pi. Pi. 2 pi over 360 instead of pi over 180. It'll save you a multiplication.
Is that good?
Yeah, that's it.
Not going to need to go back.
Yeah.
I'm confident in that. All right. Hurts my sense of symmetry, though. All right, so degrees to radians, doom guy angle. Degree to radian, doom guy angle. Okay, so if we're pointed northwards, then the angle is 0, cosine will be 1, and so we just want to multiply 1 times all these things, and if they're facing the other way, then W is, yeah, okay. So it's just going to be C times that, S times that, C times that, S times that. I'm going to, got an hour left, so pretty much got the thing working. We just need to do the rasterization. Okay, so walking forwards. Okay, let's rotate to a 90-degree angle. Then when we walk forwards, ooh, yeah, that's not working. Because we need to add in the other component, right? Technically, class ends at 3. Yeah, not today. You
What
guys
else
can leave.
do you need to add?
Well, we're not. Yeah, why was that not?
So wait, what was happening?
When we're facing to the right, the x value wasn't changing.
Was the y value changing?
Not really. So if we're pointed northwards, then yeah, we can still travel north, right? I'm holding down W right now.
Mm-hmm.
Now let's rotate to face to the east. If I hold down forwards, notice how x isn't changing at all.
And y is very slightly changing.
Yeah,
As it
because
should.
it's close to 0. So the sine of that, the sine of 90 should be 1. Oh, wait, it should be plus. No, wait, that's no W. Oh, so W is only affecting x. That's why. That's why. Okay.
Oh, right. Yeah,
Yeah.
it doesn't bother. Yeah, you have to do all. You have to calculate everything.
Yeah.
For each.
Yay, fun times. All right. Rotate to the right, and there we go. Now we're traveling to the right. If I rotate to face north, traveling north again. Yeah, okay. Now we just have to do this for the other ones as well. Oof.
Ooh, that's... Is that gonna work? I actually don't know. Let's find out. Yeah, we could do chain controls. That's what I was thinking.
Yeah, we could get it to work, but what is this?
I don't know where that came from.
Yeah, we'll just leave off strafing for now. So I don't want to go through that process of figuring out in my head. So we'll just do W and arrow keys.
Still have S.
That's true.
Just the same thing but backwards.
Sure. Yeah, I guess might as well do the other ones. We're almost done. All right.
You have to add 90 degrees or subtract 90 degrees basically from your angle. Because we're going to be moving essentially to the left, so you have to make it as if you were rotating to the left, and I'm pressing W.
Or we could. Yeah. See, this is why I'm saying if we had just computed the forward and the left vector, then yeah, either way, it's fine. DTD paste.
Yeah, so for A, you would subtract 90 because we're doing it backwards. That'll hopefully work. Although we haven't called angle mod yet.
I think the trig functions will handle that though.
Right? Oh, that's a good point. Yeah, that's actually.
Yeah. We'll find out if it's backwards or not. Or we can just comment it out. One or the other. All right, so walking forward doesn't work at all now. Oh, there we go. Walking forward works fine. Turn to the right, 90 degrees. Walking forward walks fine. Okay, now I'm going to strafe left. So we should see Y go down as I strafe left, and it does.
Yeah.
Excellent.
Wow, it just works.
Strafe right is not doing anything.
Right does not work.
Strafe right is not doing anything.
I'm still surprised.
How is that?
I'm still very surprised.
Did that work right the first time? Yeah.
Yeah.
So how did that not work?
Yeah, it's like the same thing.
It's the same thing, except just reversed.
I wonder if, because you were against a wall, weren't you?
Oh,
I wonder if it actually was.
It's possible. Yeah. Let's just try it from start. So if I
I'm
hold
thinking
down
you're probably going
A,
the wrong way.
if I hit A, we're strafing left. Holding down right, D. Oh, it's going down.
Yeah,
also.
that's what I thought was happening. It was going left both times. So.
That's because.
I guess either change the angle or.
Right. Yeah. We did a double negative.
Oh yeah, we already compensated for it being in the opposite direction. Yeah, we didn't have to compensate.
You did a double negative. All right, strafe right, good. Strafe left, good. Okay, yeah, good. Good.
It just works.
Yeah. There we go. And then if we can run around. All right, cool. All right, nice. Okay, so we've got all the trig and all the things. Input is now working. So let us do collision detection works, network. We don't care about AI. We don't care about physics engine. Don't care about yet. Let's do rendering a frame. Okay. So
this is the fun part.
This is the fun part. So we need to do a trace line through the world to see where the first world we hit. So given a position and an angle out of that position, we need to return how far away the nearest wall is. Okay. So given a position, let's make a function up top here. We're going to call this trace line, and it's going to return a double. Trace line.
Oh,
maybe I don't want to call it trace line. Whatever. So we're going to get
we should probably have.
probably.
We're going to need a resolution, like what is it, like raise per screen,
Probably.
Like how many rays to cast on screen?
We'll start with this. So we probably should be using a vector 2D instead of X and Y. Whatever. Okay.
I already have it programmed in, so you can always switch it.
I know, but then we'd have to redo that code that we just made. So whatever. We're in too deep now. All right. So given a position X and Y, and an angle. Oh, these should not be ints. These should be doubles. Double X, double Y, and double angle. And we need the world. We need a vector of chars named world. That. And you should be a const because we don't want to break you by accident. So what we want is given a spot XY and an angle, 0 is north, 90 is east, etc. Return the distance to the nearest wall. Okay, makes sense. Or the edge of the world, if there's no wall there. Okay, you guys understand? So we're just making a function. How far, like if we're looking north, how far is the wall to the north? Right? You guys understand? So like if we're standing at 5, and we pass in the player's angle, which is 0 to begin with, it should return 5. Harlan, Prado, Rosenberg, you guys kind of understand what's happening here? We're just making a trace. This is the basic sort of trace line kind of thing that you would do in a video game, where you try to cast a ray through the world and see what it hits. And we're not going to be hitting any monsters or players or anything like that. We're just doing the world. Normally you'd pass in more parameters, like what kinds of things you can hit. I understand this on a spiritual level after your line of sight woes. Okay. UE4. Okay. All right. So,
Just a for loop.
Huh?
Just do a for loop, I guess. Just go up and
Probably.
hit it.
I'll try this as a while true loop. Actually, and let's see, angle. Okay. Double distance equals 0. That might accumulate error. Do we care? Maybe.
It's just going to change how big it is on the screen, so it won't be that big of a deal.
Let's do this. Okay. Rather than accumulating into a double, which I don't think the error is going to be noticeable, we'll just say double current x equals x and current y equals y. And what we're going to do is we're just going to move in the direction of the angle, maybe a centimeter at a time, right, until we hit something solid. Does that make sense? So this is...
It's even simpler. Can we move like a meter at a time since the walls are always on a integer plane?
Yeah, but we're not looking necessarily in a cardinal direction. What if we skip 45 degrees?
Oh, right. Yeah, that's a good point.
And our position isn't integral either. And so we want to have a fine enough resolution that we would hit a wall if possible. And there's better data structures for doing this. And we should be doing the rectangular bounds intersection thing that we talked about before. But yeah, we got 54 minutes left, so let's just do it. Okay. All right. So if world.at current y .at current x equals a wall, and again we need to fix this later. So if we're standing on a wall somehow, congratulations, we're done. Break. Otherwise, we are just going to move a centimeter at a time. Our unit system is in meters, I guess. 1 is a meter. So otherwise, we're just going to move a little bit of time. So current x is going to plus equals angle double resolution 0.01. And this is a case where a data structure would greatly improve the speed of this, right? Muya, you see that? We're just going to be querying a 2D array over and over again, and this is a really garbage algorithm, but whatever. So we're just going to go resolution times the cosine of degrees to radians of angle. So if we're at 0, then it's going to move. Oh, it should be minus because. Oh no, this is x. This should be y, right? So we're going to move up. So if our angle is 0, then y will decrease by a centimeter at a time. And if we're facing east, it'll not change at all. Okay, and then current x sine. So if we're facing east, which is 90, the sine of that is 1, and so this would be plus. Okay. Maybe I should have picked a different coordinate system. I don't really care. It's a good exercise for you guys. Okay, I don't really care. Math majors out there are probably screaming in horror at me doing it this way, but I'm using screen coordinates and polar, like whatever. Okay, so yep. And then there's only one other thing we need to do, which is say if current x is less than 0 or current x is greater than world dot size, and should be greater than or equal to or current y is less than 0 or current y is greater than world dot size, and let's hope this place is square, because if it's not, this won't work. Size, then break as well. Oh, fine, I'll do it. I'll handle rectangular worlds. World dot at 0 dot size, and let's hope there's at least one row in the world. Okay, so this will work with rectangular worlds now. Congratulations. All right. So if we ever leave the world, like if we don't have a wall on the outside, it'll break when it hits the edge of the world. And then we simply are going to return the hypot of, so this is Pythagorean theorem, right? So basically what this while loop is going to do, it's just going to simply add a centimeter at a time in the direction we're looking until it hits a wall. And then we are going to take the distance from that point, from the point we started at, and that is how far away they are. So hypot is the Pythagorean theorem. So we're going to hypot. It's also what some people do on marijuana, I guess. Hypot x minus current x and y minus current y, and that's the distance. Okay, so boom. You do that for current y as well. Yes. Okay, and then we just need to we'll just put it in here and just see what the result of the trace line is. Distance to wall, the trace line from doom guy.x, doom guy.y, doom guy.angle, world. And let's see if this works, or seg faults, or hangs, or world is not declared. What I call it, map instead.
Not compiling is not on the list there.
So insignificant. So okay, and then let's see. Let's walk forward. You can see the distance to the wall decreases as we walk forward. Now it's not adding up to 10 because the wall is actually a meter in, right?
So if you turn right, does it? Oh.
I'm strafing. I'm strafing sideways, so it's still 2.6 away. So if I rotate, I'm turning to the right now.
Yeah, it got bigger and now it's getting smaller again because you hit the corner.
And then let's look straight south. See, yeah. So 3.6 and 6.3 is 10.
Amazing.
Yeah. Of course it worked. First time. First time! That's how we do.
Now it's actually not that much more to do.
I had absolutely
just gotta scale it to the screen.
perfect confidence that my trigonometry skills would hold up to the task. Okay. But do you guys understand this? Like, we're basically just, we're starting at a point in the map, and we're just stepping forward very, very small. Very, 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 very small steps until we hit a wall. This is a garbage algorithm. Don't do it in real life. But we're coding a Doom client live, so that was all of 8 minutes to do. Can you stop setting the unrealistic standard of getting everything correct the first time? It didn't compile, dude. So like, I can't really get too high on myself on this. All right, and we can add different walls and stuff like that in there too if we wanted.
I want to do drawing now. I'm so excited.
Yeah, let's do a add like a wall in the middle here or something. Okay,
Isn't
so
that exactly where we're standing?
Ooh, is it? I don't know.
I don't know. Maybe not. If you keep turning, you might run into it.
If we look south, yeah. See, when we look south,
right there.
the wall's right in front of us, and then we turn and turn and turn, and eventually, yeah. Okay, so there we go.
That's awesome.
Yeah. Now we just need to rasterize.
That easy.
Now we just need to rasterize. All right. Got to warm up my hands for this. All right. So, I'm just built different.
I guess now we need the screen size.
Now we need to. Now we can bring.
And then we're gonna probably need a resolution on how many rays to shoot out.
Oh, we're just gonna do one per column. So the resolution,
okay.
The resolution is gonna be one per.
Oh, we're gonna have to calculate how many degrees that would have to be based off of the field of view as well.
Yes.
Because one column will be a different amount of degrees depending on how many columns you have.
We're going to do one per column, but the question is how many angles, how many degrees? Yeah, how many degrees?
It'd be your FOV divided by the amount of columns that you have.
But we don't have an FOV variable.
Yeah, well, we can make one.
Okay, got it. Okay, so we're gonna have an FOV of 90. I don't know. This is kind of a weird.
Yeah.
Yeah.
The aspect ratio I calculated a while ago. It was something weird for a terminal with vertical characters.
Yeah, we might have to play with that. Whatever. So we can actually, since that's a variable, we could actually just have a keybind to adjust the FOV, which would be kind of fun. But let's get this working first. So what we need to do is say for every column, we're going to do a trace line, right? And that trace line is going to be an angle. Let's pull up OneNote. All right, so today is 5/7. What happened? 5/7. Oh, nonblock was not on. Weird. Okay. So what we need to do is when we have a screen like this, we're just going to divide it into columns, right? And so we're going to do a trace line to there, trace line to there, trace line to there. And how close it is what proportion of the screen is filled up with wall, right? And so if we're right up against the wall, this is all going to be wall. But let's say that this is a little bit further away, then we draw it to here. And if it's like really far away, then we just draw it to here. So we're going to draw a number of boxes on the screen based on how close they are. So if they're really close, we're going to we're going to rasterize a bunch of boxes to the screen. And if they're far away, we do less and less, and we need to come up with some sort of perspective algebra to figure that out. Like if they're 10 away, we draw one box. If they're 0 away, we draw all the boxes or something like that. Okay. And so we just need to figure out, so if we've got, let's say, 80 columns, actually, let's make this easier. Let's say we have 90 columns, and we have an FOV of 90, right? So straight ahead would be 0 degrees off, right? So straight ahead, the middle column is going to be the direction we're looking. That's angle, right? And then if the next column over here would be the angle we're looking +1, angle we're looking +2, angle looking we're +3, right? And then these would be angle that we're looking -1, -2, -3. So we're just going to repeatedly do a trace line. So we're doing ray tracing, right? And we're going to ray trace. My video just cut out. Hello. So do you guys understand this? So we're just gonna call that trace line function over and over again, and based on the result we get, we're gonna either draw like a wall like right up in our face, or we're gonna draw a wall like far away. You guys see that? So we're just gonna print. Do you guys understand the theory here?
Yeah.
Harlan, do you understand? Ish. Prado. So let's say that straight ahead, because right now all we're doing is a trace line straight ahead of us, and it's just telling us. You understand what we have right now, Prado? Is right now the code is just saying how far away the nearest wall is in front of us. So there's a wall 4 meters in front of us, and so do you understand that part? Like what we just did? It's just constantly trace lining in front of us and telling us how far the nearest wall is. And if I rotate, you'll see it's kind of pointing towards the corner now. It's a little bit further away. And so what we're going to do is we're going to draw a wall on the screen, and the closer something is, the bigger it is, right? And the further something away, the smaller it is, right? And so what we're going to do is we're just going to use the distance. We're going to do trace lines over and over again. And we're going to spray out trace lines like this in a horizontal fan and find out how far away the walls are in our field of view. And then we're just going to draw the walls nearer or further away on each column. So we're going to start off by just... How do we want to start this off? All right. We are currently there. Okay. Move cursor, row 5, column 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. Okay. Yeah, we'll start there, I guess. Okay. So so now we're going to render a frame. And so for each column on the screen, find out how far away the wall is for that column. We'll start off by just drawing the numbers, maybe. Right? Maybe we'll just do that. Okay. So for and I equals 0, I is less than calls I plus plus. Move cursor.
I derived the formula for how large it should be on the screen.
Okay. Move cursor 5I. So it's going to move 5 down, I across, and we're just going to print the first significant digit of the distance. So we're going to cout set precision. Int distance, I'm just going to cast it to an int, equals traceline. So we're going to traceline from doomguy.x, doomguy.y, and then the angle is going to be, we'll just start off doing 1 degree per angle, because that should be kind of in the right ballpark. So it's going to be doomguy.angle, and let's actually just compute this. So double angle offset is equal to, if we're halfway across, so it's going to be I minus, let's see, 0 minus I I minus columns divided by 2. So, let's see. So if there's 90 columns, if I is at 45, it should be 0, which is correct. If columns is 90, it should be at 45, which is correct. If I is at 0, then angle offset is going to be at negative 45, which is correct. There's going to be some rounding issues, but not a big deal. Okay. So Doom Guy angle plus angle offset. And pass in the map. Okay. So from the Doom Guy's location, we are going to look in the direction he's looking, plus some offset, and the offset is just based on what column of the screen we're on. So it's going to start off at like around negative 45 degrees, negative 44 degrees, negative 43 degrees, and we'll fix up the math in a second. I just want to make sure this works. And then we will see out to the screen dist. Length divided by distance. There's like a tan in there somewhere. Okay, so you can see that if we turning to the left, you see how there's some that are 5 away. That's like probably the corner. And I'm rotating. I'm going to turn to the right. You see how that's moving? Turning to the right, turning to the right, turning to the right. And then we should get, once we start turning south, yeah, there's that wall right in front of us. You see that right there? There's a wall right in front of us. So that's like the corner of the map is 5 away, and then there's a wall in front of us. It's 1 away, and then we keep turning, and we can see there's the corner of the map, and then the rest of the map. It's about 4 away. Okay, so I'm looking south right now, and I'm going to start backing up. I'm going to start backing up, backing up. You can see that now it's 2 away. Now it's 3 away. I'm going to rewind all the way back up to the... ooh, it's saying one of these is like 1 away. I wonder if that's a bug. Interesting.
It could be trying to print 10.
Oh. Yeah.
I don't know. Maybe.
I don't know. Either way, we'll find out. It could be some sort of trace. The trace line might... It's probably because the trace line is rounding from 1.1 down to 1. Right? And then it's saying you're within the wall on the trace line function. So what we need to do here is maybe... round or something, or maybe ignore. Maybe we can just ignore the current spot we're at. If we just ignore our current space. How do I do this? We'd round up all the time. Because technically 1.01 isn't inside of 1, right? It's considered being inside of the next one. So we could just seal this, right? Now we're not doing that down below for the collision detection, but I think that works. All right, so let's rotate south, and we should see that wall that I put up in the world there, up here below us. There we go. So there's that wall south of us. I'm going to start rewinding back up. I'm moving backwards now, and the wall starts moving further and further away. You can still see there's that wall in the middle there here. And if I back all the way up to the... Aha! It became 0. It's because it's teleporting inside of the wall. It's rounding the other direction. Yeah. It's rounding up into the wall. We don't want either of those. We don't want it to round down.
I think it would be easier to see what's happening if we actually had it drawing.
Rendering. Yeah, as it is, this isn't actually important because these bugs will only crop up when we touch a wall. We get close to a wall. So we'll just leave it at that and worry about the bug fix later. Okay, so now let's render it. Okay, so now all we have to do is take this distance and turn it into a column of wall textures. So, so we can have a ceiling texture, we can have a wall texture, and a floor texture. The wall texture could be const char wall equals x, I guess, maybe. Const char seal equals dot. Const char floor equals comma. I don't know.
You do space.
Space.
It just looks like.
Leave it open.
That's how it looks in Wolfenstein.
Yeah. We'll just do that for now. Okay. So the percentage of, so we need to figure out what percentage is going to be ceiling, what percentage is the wall, and what percentage is the floor. And so we can make it so that 10 is the maximum distance, and so we can have a wall vanish after 10, essentially. So the wall percentage, double wall percentage. We want it to be 100% when we're nose up into the wall, right? And we want it to be 0 when it's like 10 away. So that sounds like a lerp to me. So we're going to lerp between distance divided by 10. We can make that a double now. Lerp. So we want it to go from, okay, let's normalize the distance. Distance minus equals 10, normalized to 0 to 1. If dist is greater than or equal to 1, dist equals 1. So distance will be a number from 0 to 1. Yes, okay. All right, so we're going to lerp. So when the distance is 0, we want to return 100%, right? 1. When the distance is 10 or more away, we want to return 0. And we're going to lerp based on the distance. So as we could actually just do a 1 minus if we wanted. But this will give us a little more control. Yeah, that'll work. So as distance gets bigger, the fraction of the wall that's drawn will go from 100% down to 0%. Okay. And again, we could simplify this algebra by just making it 1 minus the distance, but that's okay. All right, so then the double seal percentage is equal to 1 minus the wall percentage, quantity divided by 2, because half of the remaining thing is going to be ceiling, and half of the remaining thing is going to be floor. Go for it. Right? So like there's an equal amount of ceiling and floor, right? Okay. So we might have like 60% wall percentage, 20% ceiling, 20% floor. The 60% is going to be in the middle. There's going to be 20% ceiling, 60% wall, 20% floor. And so now we're just going to for loop down and draw this. So for we've already got I up here, huh? Int j equals 0. Start at 5, I guess. J is less than rows. J plus plus. So what we're going to do is we're just going to print out a column. And so double percentage along the way is going to be J rows. And so it's like if we're halfway down, then percentage will be 50 or whatever. Okay, so let's see, we can probably do this. Okay, so the percentage will start at 0. So if percentage is less than the ceiling percentage, we're going to see out a seal tile. Then percentage minus equals percentage. If the percentage is less than the wall percentage, we'll see out a we have to do one or the other of these. See out the wall character. Nice. See out the floor character. I guess we don't need you at all. Okay. So basically, if we're 0% of the way down, it's going to print out a ceiling. If we're like 50% of the way down, then it will print out a wall. And if we're like 80% of the way down, it will print out a floor. And let's see how this looks. You. It's not correct. Let's see here. Oh, it's because we're not. We have to move the cursor every time. Okay. Move the cursor to J. Let's rotate it around. Yeah. Yeah. So we've got a.
That's the wall right there.
Yeah, that's the wall in front of us. And if I move backwards, it should shrink or something. Oh, S is backwards. I was wondering why I wasn't moving. There we go. Yeah. So as I move away from that wall that's south of us, you can see the thing shrinks. And as I walk towards it, see it gets bigger. And if I strafe, I'm strafing right, strafing left. Or sorry.
Probably want to turn off the cursor.
I thought I turned that off. No, I didn't. I thought I did. Cursor.
But then we probably would want to switch to perspective to get more accurate drawings of the walls, because they did look a bit odd.
Yeah. Well, but this was just a first pass on it.
Yeah.
What? Dang it. so ooh, went out of range.
Oh.
Yeah, there's that rounding issue, right? Where because we got close to a wall, it drew the wall as being at 0 distance. But here I am walking forward, and there you go. So yeah, so we would just need to add a little bit of yeah. So there you go. Got a working Wolfenstein client. Let's see. Snap it a little. So I'm turning. Turning, backing away, turning. Yeah. And so we need to add a little perspective to it, as you said. So,
yeah, so it's literally just the distance times the tangent of the FOV divided by 2. That's literally it. That's pretty much always going to be just 1 times. It's going to be just a linear with a 90 FOV.
Okay. For this computation here?
It would be so what you would do with the way I worked it out is you would do a for loop, basically going from, like you have from 0 to calls, and what you would do is you would have that same angle offset, but after you do the distance calculation, instead of doing like a normalization, we'd have to do an actual perspective, some kind of perspective projection on the distance, and that would be based off of the FOV. And then from there, we could lerp it across the screen size. So from 0 to the screen size, the rows.
I think all we need to do is actually just put in the FOV here.
Maybe.
I think we could actually just say doom guy dot FOV times that.
That's going to be a really large number.
Well, when you're in the middle, it'll be 0. And then when I goes up by 1, should probably turn this into a double. Right. If FOV is 90, then when we move 1 to the right, it'll be 0.5. No. We have to divide this by columns, right?
Yeah. Because we need how many degrees per column. Yeah.
Right, and I think that's correct.
Yeah. Because even the units check out because it's degrees per column times degrees, which gets you. Degrees per column times columns, which gets you degrees.
Okay, and then the only other thing we need to do is to add perspective, and so we can add perspective through color. That sounds cool, right? I don't know. So, maybe we have the walls be bright red or something. How's that sound? All right, so move cursor. Char to print seal. So rather than outputting it immediately, we'll figure out which one of these three things we're going to output. And then we can say if toPrint equals ceiling, we can make it a nice gray color or something. Set background, what is it called? Background color?
It's set BG color.
Set BG.
Something like that.
All right, so we'll make it a nice, soothing gray. Good, 100, 100. See out. And since we're doing the floor the same, to print this floor. Here. Do this even simpler. If to equals wall, we'll do one thing, and then for the ceiling and the floor, since we're just printing a space right now, we'll just make them a nice light gray, maybe. Or maybe we can make the floor a different color. Yeah. Okay. And so what we want for the wall, we want the wall to be a bright red colored multiplied by wall percentage. So as the wall gets further away, it'll get darker. Okay, see how that works. And you know, we'll just output a space as well, and just see what this looks like. See how this looks. Okay. And so yeah, there's that traceline bug again. Yeah, okay. So you can see we get a little. I'm strafing right, you know. Strafing left. There's that rounding issue again. Oh no.
Isn't it just the wall? That one?
No, because I'm looking north right now. You know what I mean? So let's rotate south.
And the color really helps, like a lot. It's making things look more real.
So that's south, and then if I back up, let's see. Yeah, you can see. Yeah, there's that center column of walls that I made there. Yeah. It's not bad, right? And if I walk forward, you can see the thing grow. And so we've got a functioning 2.5D video game client written entirely inside of a terminal. Non-blocking I/O. You know. If I back further and further away, it gets darker and darker. The only thing we're going to need to fix is when I get up next to this wall, it's going to... maybe not. But yeah, you see the wall vanishing over there because the wall percentage gets set to 0. I'm strafing left now. Walking forward, strafing left. And you can see, look, it's 3D. See one side of the wall, see the other side of the wall. Strafing right now. Yeah. Strafing left. So, yeah. I can walk forward, and that wall in the back is going to start coming into view. There we go. So, kind of cool. We just have a little bit of conflict up here. I think I need to start the one row below, and that should again be a constant probably. Let's see here. It's picking up the colors. Oh, there, it's fine. All right. Yeah. So then we can.
Can we try killing the server and running it at a higher resolution?
Okay. All right. I think the main thing we need to fix is this traceline problem here. And if we can assume that the square we're on to begin with isn't a wall, right? Like we just ignore our current one, then we should be able to fix this, right? So if the world we're at is a thing, and if we say if current x, if int current x equals int x and int current y equals int y, continue, otherwise break. Doesn't like that. Add express. Fine. Okay, so this should stop that rounding issue where we're rounding into a wall. Because if the spot that we're currently looking at is our spot, then just ignore it. Let's move on. Yeah. Because we'll just assume the player can't be inside a wall. Make sure that works. So I'm backing up, backing up, backing up. There's that pillar of walls that I made there. I'm backing up. I can't back up anymore. Let's rotate to the left a little bit. There we go. Back up. And I'm still against the back wall, huh? Strafe right a little bit. Turn left. Strafe right. See the walls off in the distance there. You see how it's getting quantitized. This should probably be fixed here. We get well, I guess it's just, yeah, it's nature of the beast because we're on a console. So
it's just the artifact of just how big the characters are on the screen.
Yeah. So yeah, let's take your approach. Let's try and kill the server, and let's at least kick it down to like an 8-point font.
8?
It's not. I know it's not that good, but it'll. There you go. Not too bad a frame rate, honestly.
You gotta turn on optimizer too.
True. Strafe right.
Yeah, the only thing that's confusing is why is when you're looking straight down, why is the wall turning into like a hyperbola instead of just like a line? Like it's like curving towards the edges.
We're not doing the perspective correctly. Okay. Turn left. Turning left.
Getting a good 0.5 frames per second.
Delta T 0.5, yeah. Yeah, so we need to fix that perspective issue. But yeah, it should be like a straight line more.
Yeah.
Yeah. So there you go. Name.cc. CC, and we should probably set the color back when we're done with all that. Set the background color to 00. So why is our perspective broken? Sorry, I think our trace line is okay. I think we're just not doing.
There's gotta be something, because I mean, you would expect without doing anything that it would end up with just that, like, you know, converging to the center look. But somehow it's like there's something elliptical about it.
Mm-hmm. What is this, a Vim editor for hats? Well, you can't read that? Put it back on 20 point bold. There you go. So, you know, you guys can take a look at this. So that was a 2-hour class today. We didn't have class last time, so maybe make up for it. But what we did from start to finish was we built a Wolfenstein style 2.5D renderer. We could add monsters into the world, so if the trace line hits a monster, we could render a monster there. We could have a projectile in the world, and so as the projectile moves around, we could render the projectile. On top of it, we could trace line to the nearest monster and to the nearest wall, so you can draw a monster in front of the wall. Right, so you can have like the trace line maybe return 2 values. 1 is the distance to the nearest monster, and 2 is the distance to the wall, so you can draw it on top. How'd you program in how to draw a monster? Yeah, you would need to know what slice of the monster, what vertical slice of the monster is, and then you'd have a sprite file or something like that. And so if you're hitting like this slice of the monster, you grab that slice of the picture data and you output the image data where we're currently printing the wall or the ceiling. And so you just do UV coordinate mapping, more or less, kind of, where you just grab a chunk of the image and you display that column of the monster. So if like just part of the monster, like its arm's sticking out, when the trace line hits it, it'll be like, okay, that part of the monster was hit, and so you grab from that part of the picture those pixels and render them on the screen, and you shrink them based on percentage. Oh, you know what the problem is? It's probably this, right? It's probably this. It's not actually this. Maybe is correct. Maybe that's. How does perspective work? Because right now it's sort of decaying to 0, you know, at 10, and so I don't think this is a natural perspective. Right now it's see what that looks like. Everything's way too close. It's still doing the hyperbolic thing. Why is floor not happening? Chart to print as floor. If percentage is less than ceiling percentage, it should be like around 20 to print as seal. Else, we subtract 20% off. If the remaining percentage is less than the wall percentage, it should be wall. So it should leave floor in there sometimes, right? So why is it not doing gray for the floor? It's doing the ceiling for both the floor and the ceiling. What's going on there? Because if it's like 0.8, then let's see. If percentage 0.8 is less than ceiling percentage, it shouldn't be. Ceiling percentage is supposed to be. Some people are ready for the workshop. Yeah. Let me just show off what we did in IS50B today. Then all today. So we have here inside of PuTTY, we have an operating 3D client, 3D game engine. So turning to the left, you can rotate, walk around, turning left, turning left, turning left, backing up, strafing sideways, strafing sideways, turning right. There should be a wall in front of us. There we go. Backing up away from it, strafing to the right, strafing to the right, strafing to the left. So this is a 3D, 2.5D game world built entirely in PuTTY, using some very simple ray tracing techniques, using some garbage algorithms, but basically we wrote this from scratch in 2 hours. So it's running in real time. It's not blocking on I/O, so it's you just hit WASD instead of having to wait on CN and stuff like that. And so you can run around and shoot monsters and things like that in theory, although there's no monsters in it yet, stuff like that. Kind of fun. So that is our class for today, guys. For IS50B, make sure you get your mod done. I posted a link if you want to do Skyrim modding. And yeah, hopefully this is a fun class for you. So yeah, I need to think about the perspective and the math behind that a little bit more. So I think that should be a straight line instead of a parabola. I'll have to think about that. Okay. Link where? Adonde. Up above. There's a link to doing Skyrim modding. So for your mod, just do something. Just give me something to work with. And make sure you get your games done by the end of the semester. That's your final. Okay. So that's it for today, guys. Thanks for coming out for IS50B. And we're going to have Stephanie Motzenbacher take over for the workshop today. Let's go ahead and stop the recording here.